Okay, we are recording. Everything you say can and will be used against you in a court of law. Um, so, uh, but if you just look at single individual variables and try to manage your circumstances like that, you find out it's not as meaningful as to see that whole processes interact with one another. And it's kind of like today we're going to talk about the payoff function, for variability. Like, what's the payoff function? That's almost like a process rather than just a variable, right? It's like a heuristic or an algorithm. So, Beth, hi. You there?
Yes, I am. Actually, you know what? It's the wrong name. I don't know. It's coming up as Hi, Beth. I'm sorry about that.
Oh, are you Hussein?
Yes, I am. Hi,
Welcome,
how are you?
Hussein. How are you?
Good, I'm good. Thank you.
That's a great way to enter with Hi, Beth. And then
no kidding.
A great conversation starter.
There you go.
Well, we're glad to have you now.
Thank you so much.
Arun was telling us all about you.
That's very kind of him.
Yes. And so, are you an SPCT as well as an SPC?
No, I'm just an SPC.
Okay. Are you a candidate, SPCT candidate?
I'm working on it,
Okay.
but I'm a distance away from it at the moment.
Okay. Well, he was. He thinks very highly of you, so he was trying to give you a promotion.
You don't have to be an SPCT to be a smart person.
That's right. I'm sure you're worthy of his esteem.
Be pretty knowledgeable and not have the T after your name,
I'll take it if you're giving that compliment. I'll take it. I need that today.
Yeah. Well, we're thankful and glad to have you here. Now, I don't want to disappoint you. He probably got you all teed up, saying, "Man, Don's been coming every time, but Don cannot join us tonight." So I hope you.
That's okay.
This means you have to keep coming, Hussein.
Absolutely.
It's not a one and done. You have to keep this going. So.
Absolutely.
We didn't expect him. In fact, he told us up front he couldn't join us every time. We're hoping he'll come, especially on the more difficult chapters that we get into later. So we're on chapter 4. This is our 5th session because we decided by consensus, because we make team agreements, because we're so agile and lean, that we would do half a chapter a week to cadence and that quantity, that scope. So I don't know if you've had a chance to reread this book recently, but if you do want to stick with us, it's a pretty light burden to read half a chapter a week. Don't you agree, guys? I mean, it's not, even though his stuff is pretty dense and somewhat, it's kind of, it's not a superficial fast read. It's meaty stuff. Half chapters have been very manageable. So
and it's a weekly meetup that you
it's a weekly meet on Monday evenings. Yes.
Perfect.
And we are recording, so be careful what you say about your boss and and anybody else that you don't want it to come back on you. So there's several people, especially we had some Krakow people are interested in. One of the organizers is in Bangalore, and they want to actually start these in their time zones, but they wanted to kind of listen to our conversations and see how this is going in the States, and especially when Don's there.
Sure.
So we were just talking. I want to say your name correctly. I was saying Hussein, but it's actually Haas' name, right?
Yeah, exactly. You can even just call me Haas. That might be easier for everybody.
All right. Like the Cartwrights, like Bonanza.
That's right.
There you go. There you go.
Down in Houston, right?
That's right.
Yeah.
Awesome. Okay. So we were talking about random processes instead of random variables. Sometimes you need to be thinking about process sort of functions, how they interact with one another rather than individual metrics or KPIs or variables.
Yeah, I liked how I laid out the thinking errors early in the first introduction about the difference in manufacturing and product development.
Right.
How he said because variability sometimes leads to bad outcomes because generalized into variability always leads to bad outcomes.
In manufacturing, because it's repetitive, fixed work with fixed types of product items that have a sort of a fixed ecosystem. So the manufacture of them is sort of uniform and homogeneous. So variability ends up almost always being a negative. But he said in product development, it can be the opposite. In fact, to have innovation, you purposefully inject variability to get some innovation. But we're getting ahead of ourselves a little bit. So yeah, let's go ahead and go into one. It can create economic value. Anybody want to riff on that a little bit? Arun, did you have some thoughts on that?
Yeah.
You have to probably also focus more on the payoff function, not just concentrate on the money factor, or
Right.
how he sees it.
Yeah, and he mentions, he was talking about the asymmetries of economic value and variability, like with stock options. The higher the variability, the bigger the return. The further away from your strike price, the better. So different systems, variability can actually be absolutely mandatory to get the benefit.
But not in product development.
That's
no,
what
product,
he said.
you said product development, you need it if you're going to do what?
Innovation or new
Innovation,
product.
exploration.
Yeah, but not to the extent that you need to do it in the marketplace.
That's correct.
Right. These are different systems that have different payoff functions, right? Their payoff f of x is not the same with one another.
When I saw the first thing, I thought of all the science that people just, the happenstance of scientific discoveries. Penicillin was happenstance.
Yeah.
Velcro was happenstance.
Not finding a good wife was just totally dumb luck.
Those were exaptive situations instead of adaptive situations.
Yeah, just noticing something, right? Noticing a change.
Well, exaptive is the occurrence of things that you didn't expect, whereas adaptive is you had a hypothesis, it happened to you, and then you adapted.
Oh, yeah, that's true. But I think both can apply to product development. I think you can discover things by mistakes, or discovery, like pure discoveries. Like I had no idea. And like you said, adaptive, like, oh, that worked good, but let's make it better.
Thank you, Arun. Where's the man? Unless that's Neha. Is that Neha?
Yes.
Oh, you're so good.
Keep us on track.
She's always good about this. Okay. Awesome. Good thoughts. Okay, so the principles of asymmetric payoffs. Payoff asymmetries enable variability to create economic value sometimes. Now, the Bernoulli trials, thanks for going and get the links for those, Arun.
Sure.
He did references them. I was wanting to go look those up individually as well. So did everybody know what the Bernoulli trials were? Anybody not sure what those are? That was there's always two outcomes, like flipping a coin.
Yeah.
And it was the math behind probabilities on that and he proved that you can, if you make small batches, in other words, don't have large samples, you can come up with much more consistent predictability and probability. Kind of obvious. But I mean, like if you do 4 flips instead of 4,000, And then the Black-Scholes formula is like, it was in like 1978. It was won a Nobel Prize. Black died before the event, and they don't give it posthumously, but they acknowledged him. But this formula is essentially how they have been determining the price of stock options ever since. And there's a little Black-Scholes calculator link. I thank you for providing that. That's fantastic. It looks like a little Python program, cosmetically. I don't know exactly. Oh, CFM. Oh, I see what it is. So anyway, that was great, Arun. Thank you. But in the presence of payoff asymmetries, higher variability can create higher economic value, like the examples we gave earlier. So I had a question. In the example that he gave, variability was caused by innovation, exploration, and experimentation. Increased variability in a vacuum probably would not increase value, except in things like stock options. It all depends on the nature, behavior, of the payoff function. So I think that's not a question. That was just kind of a summary of the thoughts together. Anybody disagree with that or have other questions or thoughts about?
I'd like to add to it.
Yes, go ahead, Jack.
So let's see. Lean says get rid of waste.
Mm-hmm.
Six Sigma says get rid of variability.
Yeah. So
Lean Six Sigma says get rid of both of those.
Yeah. So
you get rid of both of those, you have no innovation.
So he started his book off with the wonderful Mark Twain quote. It isn't what you don't know that hurts you, it's what you think you know that just ain't so. And then he goes on and he talks about how wonderful Goldrat's theory of constraints and critical chain, all that were to shine a good, meaty light on a lot of things that are true physics-wise, you know, but that it's too simple. It doesn't consider some economic layers and that it can lead you right off the cliff. He says the same thing about Six Sigma. You know, there's a lot of things, and if you get religious about these different schools of thought without continually applying principles and thinking, and if you just pick like, you know, Q's are always bad or Q's are always good, or you know, or over using the decide at the last responsible moment, or all these slogans, you'll end up hurting yourself by trying to make them catchy, pithy, oversimplified things that are, those are based on trends that are very often true. That's why we end up with those slogans, but they will betray you. And so that's one reason this book was so profound. I think it really shone a light on a whole other layer of thinking. The problem, I think the challenge with everything that Don gives here personally is it forces you to think all the time. and people who want to do processes and methodologies want rules so they don't have to think, instead of having to reapply a principle to every single context that they have to cognitively reassess everything all over again. It's painful and difficult, hard to scale, hard to disseminate to a large group of people for a common practice. There you go.
You guys know this book?
Principles by who?
This is Principles by Ray Dalio.
I've heard
So
of
he built a business on algorithms.
Interesting.
Interesting.
He's a gazillionaire, right?
Oh, well.
I had a
And
very
he did a lot of thinking. But once he did the thinking and he figured out the algorithm, then it was self-sustaining.
Yeah.
You know, money machine.
Yeah, there's a company in Austin that made like $350 million a year. It's just 3 guys, and they came up with algorithms, heuristics to trade stock electronically.
I have a very basic question about figure 4.2 and 4.3. I understood that from the reading that 4.2 or 4.3 is a combination of both the graphs from 4.2. This is on page 88. But it seems to me that you can see on graph 4.3 the line starts at 0. Why isn't that negative like this? Why isn't the same as basically a straight line, a straight negative line until it gets to the strike price? Anyone understand that? Here, I'll show you.
I got it.
It's right. It's on the screen.
It's on the
Like,
screen.
why is that not down here? Because over here it's negative, right? It's negative till it hits the strike price. But here it's 0. Oh, 0. Why?
So you're the programmer in the group, Steve. And this is math.
Yeah.
So maybe you're asking the wrong people.
Oh, sorry.
Explain
No,
the math.
That's fine. I didn't think about it too much. I just don't see what it is immediately.
Anybody good on math?
like it makes me think I misunderstand it. I thought this was like the addition of those two things.
This is associated with the strike price though, right?
Yeah.
To figure out when and where to buy.
So let me tell you the takeaway I got. I can't answer. I'd have to reflect on it. I'm glad you brought that up. I like one reason I wanted to do this study with a lot of bright people like yourselves is so we could get through tedium like this and co-think it. But I wanted to mention that the big takeaway is that the product development's the opposite of these things, because this has sort of an unbounded payoff, but a limited downside, because the strike price limited your loss to a fixed limit. But the amount of earnings is kind of unbounded based on what the market does. Whereas product development is the opposite. You can spend an unbounded amount of money on something, and not that the real potential benefit of that feature, once you get it coded and QA'd and test deployed, is probably fairly well known, and it's fairly finite, right? So the point he's trying to make, though, I think, is that payoff function for product development is the opposite, and you need to be mindful of that when you're making these decisions. Am I oversimplifying?
But there's a solution. He gives the solution to it.
Yes. Okay. What was
time box?
Okay. Yeah, the time box. Okay. By the short time box. Go ahead, Nia.
I think based upon your explanation, Michael, I have answer to Stephen's question, maybe. But so when you start, it's expected payoff versus price. So in the beginning of the process, you have spent $0, and then you spend money till you reach the minimum marketable feature or minimum marketable thing that you can sell things for. And then you start increasing your revenue if you have a good plan. And once it reaches that optimum thing, if you add more features, it doesn't, you're just spending time and money and not bringing additional revenue. So it's actually going down, your profitability.
Right, because you're spending more money without more revenue.
Yeah, so I think that's what the expected payoff versus price is doing. Starts with 0 and not like the stock price, which is all below all the way through.
Yeah, I mean these are different graphs, right? The first one we talked about 4.3 is the payoff is the area under the graph, right? I mean you're still getting diminishing returns because your probability of making that much goes down. Your expected return goes down over time. Like you know, if it's a great discovery or just a modest discovery, most of your payoff, I mean, you've got most of your payoff by here, right? You've got most of what you're going to get right about there. Yeah, right about there. Having it be more successful doesn't make any difference, right?
Right.
So this is an area underground, and this one, I don't know why I changed the graph, but this one, right?
So maybe the starting point, Stephen, like, in 4.2, it's like the starting point is you've already purchased the option, and the strike price is where you purchased it. So that it's flat until you sell it. The one in 4.3 may be I haven't purchased the option yet, and it starts out, I'm opening a new company, stock's worth 0, but as I'm starting to do things, its stock starts increasing in value. So the longer I wait, the more I have to pay for it to lock it in. And then that becomes my strike price because I locked it in at that point. I'm making that up. I hope it sounds good.
But I want to note that this one, sorry for swearing, sorry. This one, right? That one shows a cumulative. Like it's not, you're basically making infinite money here, right? I mean, you can go on and on. The area of that curve gets more and more and more forever. But so it's already done the integration on this one.
This is what Nihal was talking about.
Yeah.
It doesn't help to pay any further after that point.
And that probably also means that you don't get any value once you reach the point.
That's right. So there are different graphs here. That's all I'm saying. Is one is the area under the first one is area under the graph is the total profits, and this one is already done the integration on that function. So it shows the total. That line is the cumulative of the total price already. they're not the same. They're not showing, these graphs are not showing the same thing.
Yeah, I agree.
Right? And thus, what I'm trying to say here is that although he makes the point that you can have unlimited downsides, both of these things have limited upsides.
Right.
I mean, he says, I'd like to know what he would think about, he's saying unlimited upsides. Well, no. It's not the
He
case.
says in product development, there is no, that does not apply.
Yes, the downside doesn't apply, but the upside of both of them applies. I just don't agree with I just don't understand why he's saying there's unlimited
I don't
upside.
think either one of them in the real world, either one of them's practically unlimited. They all have limits, but they can be extreme. You can waste millions of dollars on a useless product, and you can earn millions of dollars on a stock that you didn't know was going to go nuts. But it's not infinite.
But there's still diminishing return, right? I mean, I guess technically the product development does stop. I mean, it gets to zero. The area goes down to zero. Actually, probably turns negative. But the stock price, in theory, you could have like a 1 in a billion chance you're making loads of money, right? In theory, but chances are low.
Y'all want to go to V3? Principle of optimum variability.
I love this one.
Minimize or maximize. Okay, what do you think the point was here? Anybody?
It's the old adage that he has throughout the book of not ever using the word always.
Yeah. Yeah. Stop saying Q's are always bad or Q's are always good or all these things. They may almost always are bad, but not all. There is an important difference between payoff functions of stock options and those of part. Okay, we just talked about that a lot.
Yeah, I love that he said your optimum failure was 50%. And
Isn't that great?
I loved how that's echoed in the Scrum. Well, I don't know if it's a Scrum guide, but one of the books I read about Scrum, it says if you're not failing half the time, right? Sorry, not failing. If your estimates your forecasts aren't right half the time, you're not doing it right.
Right. I mean, that's for risk management. That's what you mentioned when we first started this conversation tonight, Stephen. Is he was saying you get the most information at the 50th percentile out of your test. I mean, if you set it up where it fails 50% of the time, you get the most information from that.
I also loved what he said on the next page about exploratory testing. And I loved how he distinguished between exploratory testing and the information or validation testing. That was awesome. That was like really very insightful.
Okay, go ahead.
And as a guide for exploratory testing, right? I mean, I do this, I think I kind of do this naturally, that you're looking for those areas where it's 50-50 to fail, right? You don't go for the ones where you know this is going to work. That's not exploratory testing. You don't go for the ones you're sure it's going to fail. You already know it's going to fail, right? You go for the ones where it's a 50-50 chance. That's what you're looking for in exploratory testing. That turned a light bulb on for me.
Yeah.
But he also adds to that we should make the decision of what to experiment on based on whether or not there's an upside. Because it costs more to do the experiment than the value that is potential to come out of. So that is linked to small bite-sized morsels and the feedback loop, the shortened feedback loop. Did you guys see the quotation here? It says, so avoid oversimplifications like eliminate failures or celebrate failures.
Yes.
So celebrating failures is a big part of Agile, and I've never liked it.
Yeah.
I've never liked it.
Well,
and he says that's not nonsensical.
It may be part of Agile culture, but it's not part of the manifesto nor the principles.
Yeah.
I don't know where they came up with that. You know, it's like fail fast. No, I don't want to fail fast. I want to learn fast.
Yeah. Well, fail fast.
If I can learn without any failure at all, that would be wonderful.
Well, fail fast has its context, right? Anybody want to give an example of the win of failing fast and what that means?
I don't like the word. Well, I mean, yeah, it just means if you can have shorter experiments, you could learn faster.
That's all. Less, and you learn faster. That's also the 4 flips instead of 4,000 flips of Bernoulli. And if you can fail and get it and learn from it and move on, instead of thinking you have this right solution and going to this big investment on this big Hail Mary pass gamble, and then having a big blow up at the end. SAFE is great for showing that over and over again. That's why they have the solution sets, you know, and
right. Yeah, when you increase the chances, when you increase more, then there's more chances of failure. Or
Yeah, however, I have been in organizations where they just go to fail fast period. I failed 10 times. It's like, okay, what did you learn?
What was the value, right?
My point.
Yeah.
Yes.
So oversimplification.
Doctor, it hurts when I poke myself in the eye. Well, stop poking yourself in the eye.
Yeah. But here's what captures it, right? Halfway through 94, an unexpected success has high information content, as does an unexpected failure.
So,
well, unexpected failure is information.
Yes.
Right.
Yeah. But I think the unexpected is the key word here, right? I mean, you're looking for things you don't expect, I think. Well, maybe I'm wrong about that. I don't know.
and for that,
assumption.
That's what we hope for in experimentation, is the unknown unknowns.
Yeah.
Exactly.
Yeah.
If all we're doing is confirming our hypothesis, what benefit is that?
Yeah. So, for example, you try this API in programming that's going to do maybe shade some graphics for you, and it doesn't work. You learn from that.
I think this thing at the end is something that speaks to Jack's point. He says, unfortunately, most companies do a far better job of communicating their successes than their failures because they're trying to look good. They carefully document successes but fail to document failures. This can cause them to repeat the same failures. Repeating the same failures is a waste because it generates no new information. Only new failures generate information. Of course, not all tests should be designed to maximize information generation. Some tests exist to validate the design, not to generate information. On such validation tests, we should strive for 100% success. Product developers should clearly distinguish exploratory testing, which is for information, and validation testing, which should be optimized for high success rates. Finally, we should recognize that we are not simply interested in resolving all of them.
So, Michael, I have a question on
this. Sorry.
If exploratory testing, which is normally manual testing and expensive, is to generate information, what is the value of doing automated testing then?
So I think that's the latter type. I think after you've basically, let's say I'm doing test-driven design and I code I build the test first and code my solution into existence from the test harness. So then I get it running and it's passing all the tests and the assertions, and I hang that test on an automated test rack to detect regressions if someone else pokes my code in the eye intentionally or indirectly or directly.
But what new information have I gotten?
Well, that's this latter part, is to validate that it's still healthy after something else has changed. So there's not some second order effect causing my stuff to stop working. So he's saying that don't oversimplify, like testing just has one mindset or one philosophy. They have different concepts and purposes, right? And
I just know that there's somebody out there reading this book and coming to their own conclusions about certain things. And I know one day I'm going to come across somebody and say, you know, I was reading Reinertsen's book and we shouldn't be doing this automated testing. We should only be doing exploratory testing.
I think he says several things that support DevSecOps. In fact, this highlighted paragraph, absolutely, for validation testing. And then the last part, in fact, it was in the notes. I said it's basically, let me go to the end here.
I mean, it clearly doesn't say that, right? He's clearly saying there are two kinds.
Yeah.
It's clearly saying that
if people read a segment of something and don't read the whole thing, I mean, people
But
do that.
you hear people saying sometimes, you know, I don't want to invest in TDD and BDD because I don't have time for this. We have to find innovative solutions today, and we can't be spending time on TDD and BDD.
Yeah.
Because we're not doing exploratory testing that's giving us information on that allow us to pivot.
Which
That's
I think,
basically what
Jack,
they're saying.
I think it's the consistency here is to not make a religion out of any of these things. These are all like patterns that we can learn, like design patterns. You can overuse design patterns. You can put a strategy pattern when all you need is an if then else statement. You can over-engineer things with patterns. And with TDD, if you're trying to do exploratory prototyping, that's not the time necessarily to be doing TDD. But if you're building pretty solid plan design work that is, or maintaining or expanding old existing or legacy systems, or there's a time to do TDD, and you can get to where it's like a 10% hit instead of a 500% hit. A lot of people oversimplify things. So the thing about TDD is you need to have the support of the organization to provide all the mocking and libraries of mocks and stubs. Because if you end up having every guy do his own mocks and stubs, it will greatly amplify the time it takes, and it distracts him from doing the test that he's interested in about the logic of the code. But if you have people who, like a support group that build libraries of mock and simulating in-flight environments, runtime environments, so that person can just sort of snap into that simulation and then then they can really crank out TDD like that, and you never want to go back once you've been there because it's just very satisfying. So there's a right way and a wrong way to do anything. If you buy a $600 million fighter jet and some banana republic, and then you're driving around on the ground and the wings are hitting the trees and the stop signs and you're cussing and saying, man, I like my old car better. I mean, it's just, you have to use it properly.
The intent of, I mean, they're getting the intent wrong, right? The intent of doing test-driven development is so that you can deploy with the assurance that it's going to work. There's nothing else to it, right? The secondary, the side effect, the benefit of TDD, doing good TDD, is that you can pivot faster, right? Mm-hmm. It's not pivoting the output faster or the outcomes of the output faster. It's pivoting the architecture faster. You can't go from, I'll tell you this, you can't go from something that serves 100 customers to 1,000 customers, to 10,000 customers, to 100,000 customers with the same architecture. You cannot do that.
Right.
If you ever want to be able to do that, you'd better have TDD in place when you get 100 customers, so that you don't spend $1 zillion, so that you can get to 1,000 customers or 10,000 customers.
I couldn't agree more, Stephen. It's needed to validate all that sorts of scaling, different kinds of pressure, but also I was doing TDD in 1999 and 2000, and it's magical. Because one thing it does is it helps you eat your own dog food, drink your own champagne, because when you're coding APIs and you're just trying to make them behave a certain way, it's easy to do something that's very painful to use as a consuming coder. But when you're driving these APIs with your own TDD, you're seeing how unpleasant it is to try to use the signature that you created for that method. And it's like, oh, if I was using this, I'd want to kind of, create an object and pass the object. So it really makes much higher quality in lots of unexpected ways.
Yeah, I agree with that. It intrinsically makes your code better quality, and for many reasons. The two are: one, testable code tends to be good code, and tested code you can fix your mistakes in your designs transparently and without risk. Right? It's a low risk thing to take. And don't let me over this too. Just because you wrote tests for it doesn't mean it's going to work. You're just saying that that parts of it work.
Right. And also you're exactly right, Jack. If I'm going out and prototyping something, I'm not worried about TDD at that moment. I mean, if I'm going to test a little, in my sandbox.
By the way, the first time I implemented TDD in a company was almost 10 years ago.
Mhm.
And the director of engineering quit because I forced the company to do it.
Nice.
Yeah, there's people get.
All right.
Yeah, but a
So-
lot of that's because of the oversimplified thoughts about everything. Having TDD without the mocking support is very painful. Having TDD for everything.
I
when
didn't
it's
tell
not-
him how to do it. I just told him what the definition of done was.
Yeah.
And he
Yeah.
said,
Yeah,
I can't do it. I said, I'll
I
go find.
agree.
Yeah.
Yeah, I agree with Jack. You know, we've been using TDD for so long, and yeah, the mocking framework has to be there. It has to be, a company has to be matured enough to have a proper mocking framework.
Yeah. Yeah. I mean,
mock-
otherwise, the person is going to spend 700% of the time it would have taken them and not be contributing to the actual test, but just setting scaffolding so they can run it. In. Okay, that was a fun digression, but it is relevant. So I think everything is these things are all simultaneously true. And the spirit of Don Reinertsen is don't oversimplify things, but see the nuanced truths of these different. These are patterns that can help you or hurt you depending on how you use them or how you apply them. Right?
Hey, I've got a question about V5. On the bottom of page 95, it says something about the example were 9 engineers, 9 engineering specialists. Should there be 1 team of 9, or each engineer put on 1 team? And I wonder if anyone could reflect on that a bit more, or explain that a bit more in terms of reducing variability. He says, if variability were high, it'd be better to operate the 9 manufacturing engineers in a single resource pool, combining the variable demand of all 9 projects.
Where are we? Look on the screen and tell me where we're
Next
at.
page, isn't it?
That's V5.
It's
Yeah.
96.
Yeah. Page 95, 96.
There you go.
Bottom of 95, top of 96.
Where'd it go?
Yeah, it's the top. It's the top of manufacturing engineers in a single resource pool, combining the variable. It's already highlighted on the left-hand side, top of left-hand side.
So garbage in equals quality out.
He said, this is the one time that's very rare. and you have to realize it's an average quality. So the idea here, his example here was the investment portfolio or mutual fund, where by blending the risk of all of them, you end up with a fairly predictable, stable average return. In spite of the variability or volatility of individual stocks in the portfolio.
So he's saying, like for the engineering example, he's saying if it's not much variability, in other words, if it's database people, for instance, and you know that every feature has some database work in it. Cool, split them across, make them pie-shaped or comb-shaped. Excellent. But if you have another another set of projects where I don't know, maybe it's a UI specialist. I don't know. I don't really know. But sometimes you need them, sometimes you don't. Like half your work or 3/4 of your work is back end, and only occasionally do you get to do front end stuff. And that's split across work randomly. So it's across the teams work very randomly. Then make one pool to service all those guys to reduce the variability. In other words, you're pooling the variability across your projects.
Oh, is that what variability means? I thought the variability word here means that the performance of different people is different. And
No,
so you're averaging the performance of the team by putting them all together. That's what I understood that to be. But Stephen is saying something different.
I thought it's the complexity of the project, like Stephen said. If the project is simple, you can assign them to each group and everybody does their own stuff. But if it's a complex project with many variables in it, then it's easier to pull from a common pool with specialists or somebody like that.
Yeah, exactly. If the variability is high, like if it's sometimes really hard, maybe I'm not sure if it's the work items, like sometimes there's a lot and sometimes there's none. or if he means like sometimes it's really hard and sometimes it's really easy. But I think either would apply, right? If you've got 6 projects and each of them needs this specialist,
Mhm.
and either the demand is variable or the work is really variable, you can reduce the variability by pooling those guys into one component group, let's say.
That's what I thought.
Component group.
Yeah, that's how I interpreted it too. We have some teams at my company where like they end up working on a common set of technology that we don't have enough people to spread them out among like all of the, I mean, we've got like 11 trains right now and we're going to have more than that eventually, but we don't have enough people to spread them out. Plus they're trying to do kind of like tech modernization as well. And so they put all of those people on a single team so that like that single team has a focus on kind of the overarching like impact to all of the other trains until they can get over kind of the hump that we've got with like our technology situation. And then they're also kind of taking the longer term approach, which doesn't fit into kind of like this piece that he's talking about, but they're also taking a longer term approach to educate people on, if we're going this direction, this is what like the general approach to working on this system needs to look like so that we have less variability going forward, because things got so out of hand like on some systems that the variability was causing a lot of problems.
Interesting.
So
Actually,
that's not unlike dual track Scrum and parallel work where you have a UX team that does work 1 or 2 sprints ahead of another development team. And that's the way we used to do it, you know, what, 6 years ago? That was the common mantra. That's not what's recommended anymore. It's the embedded, that's the example that he gives. You put one person, one expert on each team, you embed them, and then you drive T-shaped learning through mob programming.
So this is not saying, so first of all, one thing about his book that we're all seeing is at any one moment, it's easy to think he's recommending this. And what he's really doing is showing you all these causal relationships, right?
Mm-hmm.
So he's not saying your throughput's better. He may be saying maybe your qualities. He's just saying, here's your handle, here's your spout. If you put them, and a lot of the embedded, and a lot of these embedded things are like operations to help prevent silos. Like, so we get DevSecOps, we have ops people everywhere so that things don't rush up to ops and then hit a wall because there's.
It does have the word flow in it, right?
Right.
Yeah.
So this isn't the highest flow necessarily. It's more predictable. Less variability is increased predictability. So
well, and I think it depends on what you're trying to optimize on. So like if you're trying, so this reminds me of because I was actually just reading this earlier today. This reminds me of the article about feature versus component teams in SAFe.
Yes.
Where he talks about like when whoever wrote that particular article, but they talk about like deciding between creating feature teams where you spread out all of your experts, like one on each team, or creating component teams where the component team is focused on a specific set of like a specific technology component or set of technology components.
Right.
And it depends on what you're trying to optimize on.
Right. And there's all kinds of trade-offs, and it says that in that white paper, and it talks about the fact that the components are almost unavoidable in long-lived products, flagship products. They tend to happen, and architects tend to like it. And you end up with a czar who protects the quality of that product, like that component, to make sure that everybody doesn't just have their way with it and it turns into a big mess. So there's trade-offs. And the problem with component teams is it hurts flow for why? How does it hurt flow? Too high a ratio of component versus feature teams causes.
You just end up waiting. Everybody ends up waiting.
It creates a lattice work of dependencies that just really bogs things down. So it's like pay me now or pay me later. These are all and he said, you want to shoot for no more than 30% components was like a top ratio. And
no. I learned 20.
Huh?
I learned 20 in 2014.
Oh,
SPC
20? I'm
class.
sorry.
Leffingwell, actually, he was big on that.
Okay.
It's a, you know, but it's funny because he talked about it in his class, but it's not in any of the documentation anywhere.
It's in that white
So,
paper.
and that's problematic also because we have this thing called service trains that operate on Kanban and aren't doing Scrum at all. And so the whole component team issue goes away.
So
you know, it all goes away.
Here's the thing. One reason I like to read the source books that inspired things in SAFe. SAFe kind of helps me have the strafing run over the whole thing and see how it all comes together. You know, Eric Rees and Deming and Reinertsen, all that. But it doesn't satisfy you because it kind of leaves you like, well, why did we end up with a 80-20 ratio? Well, you know, but
where'd that come from?
And even that is just a rule of thumb, and there are exceptions to it. So it's good to go back and really. I think it's great to use it as a reading list. It's a 3D reading list instead of a linear reading list.
Well, Leffingwell said in the class that if you have less than 80% of your teams being feature teams, then there's a good chance that your value stream identification was done incorrectly.
Interesting.
But again, this gives us the basis, right? I mean, what Don's saying here is that look at the variability and see if it's justified, right? Again, he's saying that this variability in work is something that can justify a separate team of specialists.
We want simple formulas, but this.
So there are SPC team candidates that I know that propose that this thing called feature teams is not an issue at all, and that and this value stream mapping stuff is a bunch of hooey, and they cite large scale SAFe initiatives that went from waterfall to SAFe, but not with true organization around value. And they show improvement without doing the value stream identification and organizing.
So what does that tell you? No, I think that, so you can get improvement without having an optimal.
Yeah. I mean, just having the dev teams work in isolation, doing Scrum instead of waterfall gives you about 20% improvement. But that's only 20% of what you can get.
Yeah.
It's like, okay, I'm going to leave all this stuff on the table because I don't want to change.
Well,
right?
Maybe it's not appropriate to change the people who are working on a legacy app that's going to be thrown out in the next less than 5 years.
Yeah.
And try to do a complete reorg.
Then it goes to SAFe talking about that separate operating system that they kind of pitch in 5.0, where you basically don't try to change the old buzzards doing COBOL. You create, you know,
like a dual operating system.
You create a separate operating system. It's kind of like a vellum layered on top, and then you migrate over as you can.
Well, it's just triangular pattern. That's nothing new.
Yep. We're doing that right now at Sabre. I'm not one of the old farts running the COBOL as much as it may appear. So where are we now? Okay. That was great, Stephen. Thank you.
Yeah, it was a good discussion. That really helped me think about this some more.
I really liked V6.
Okay, you want to speak to what you liked about V6, Jack?
Oh, yeah.
Well, there's this one thing, it says forecasting 2 years ahead is not twice as hard as forecasting 1 year ahead. It's 10 times harder.
Yeah. Well, it's
rhythmic.
Major forecasting, which means tongue in cheek. In fact, one thing that I haven't seen him say in print here yet, but a dictum that I've found very useful is, when does a roadmap become a queue?
Oh, yeah.
When everything is committed in every single.
When you make it a commitment instead of
that's actually a question on the SPC exam.
It is, yes. How many SBCs do we have here? 4, okay. All right. Well, so, but how many certified SA? Anybody have any other SAFE certifications?
I have quite a
I'm
few.
accredited to teach 9 of the courses.
Awesome. And
Yeah,
then-
I've got almost all of them you would need for an SPC, but I don't teach the classes, so my company didn't pay for the SPC.
Okay, I got you.
It's
Yeah,
a little
that's
annoying, actually.
That's an investment. That would
Have a
take
Right?
someone.
I have a funny picture with Don, not Don, Dean.
Dean.
Where we were wearing the same blue shirt, same blue jeans. He has his little white beard. I have my long white beard. And
You look just like him.
well, I told him, I said, I'm here not just to be an SVC. I'm here to show you what you're going to look like if you don't take care of it. Anyway,
I love the contradiction between V5 and V6. And that V5 said that combining pooling risk, that a lot of little estimates make it good. A lot of small tasking makes good estimates, right?
Yep.
And this one's saying no. Well, too much gives you bad performance. I love the contradiction of those two things.
Well,
V5 and V6.
it's the handle on the spout. Smaller scope leads to faster development, which shortens time horizons.
Yeah.
He doesn't say you shouldn't have 3 and 5 year time horizons. That's part of SAFE, but you don't make them queues. You don't make them commitments.
Long queues bad. Long queues bad.
Long queues. We can't say long queues are bad all the time, right?
I didn't say all the time.
Well,
I would never say always.
we're talking about forecasts, right? I mean, he's just talking about forecasts right now, not queues. That looks like, I don't know.
The forecast, if you commit it all, then it becomes a queue. So it's
Exactly.
just the commitment.
Oh yeah,
which
but
is
no
the
one
difference.
takes anyone seriously who says they got a 10-year plan.
Well,
That's
there's some
ridiculous.
more project managers that take it seriously.
Yeah, but no one can take that seriously. The world changes too fast.
That's
It'd be just like the communist 5-year plan. That was insane, and they paid for it. It's the same.
Insurance companies have 5-year plans until,
Until COVID
Until-
hit.
until a hurricane hits, but and then they adjust their model accordingly.
So we've already talked about the many small experiments produce less variation, one big. That's kind of repeating that. And then the repetition principle. Repetition reduces variation. The effect of breaking large tasks into many small tasks is more than statistical. When we have many small tasks, we have an economic incentive to systematize. This is where you automate. You're motivated to automate if you have many small tasks. This foreshadows DevSecOps automation, CI/CD pipeline. Well, we are at 7:33, which is 3 minutes after the hour. We usually schedule an hour and 15 minutes to give us time to do some retro or some reflection. Is this still working for everybody?
Yeah, it's nice seeing you guys.
Yeah, that was good.
Bunch of smart people.
The only problem I have is Roshan talks so much, nobody can get a word in edgewise.
What's up with
Talk,
you
talk,
with
talk.
that, Roshan? You're going to have to lead the conversation next time.
That's right, Roshan. You're leading next week.
And I want to thank you all, and I want to thank Arun for introducing me. Next week I'll be prepared. I actually gave my book a copy. I gave a copy of my book to a friend, and you know what happens when you give away.
You never
things
give it back.
Exactly. So it was supposed to be borrowed, but I think it's been like permanently borrowed. So I ordered another copy. It should be here by Thursday.
You know, they're really I was surprised how pricey it's gotten.
Yeah.
It's increased in value.
You can get used copies though.
Yeah, mine's used. Half the price.
I do the Kindle. So Haas, it's a blessing to have you. Thank you, and we do hope you will continue. We have a few people that there's always like 2 or 3 people different. I mean, we're missing 2 or 3 people this week.
Sure.
And frequent in the past. Perhaps they were clairvoyant and knew that Don wasn't going to be here today, so they bailed. But please keep coming.
Absolutely, absolutely.
All right.
Yeah.
Good night, guys.
All right. Good
Thank you.
night.
Take care. Take care.
If you want to put anything on here, you know where the document is. Please add your feedback. All right. Good night.
Thanks, everyone. That was fun.
Thank you. Have a good night, everyone. Bye-bye.
Good night.
If I talk too much, let me know.
No, you're great, Stephen.
This is good.
Yeah, thank you,
And
Sarah.
thanks for that practical experience, Sarah. That was awesome to hear that what you all were doing.
Yes.
You're specialists.
Yeah, I feel like vaguely caught up. I have not felt like I've been caught up for these discussions until tonight. So
Awesome. So now you're going to lead the next one then.
right.
This really was the best chapter, I think. This was the best. I think this is the best chapter, this one.
Everything else just seemed like it was building, and
Yes.
it didn't seem connected to anything.
Yes. I think it's going to get more and more interesting as we move further.
Yeah.
Okay, guys. Bless you.